Morning class, we're going to go over section 4.5, applying ratios to probability. So probability is the likelihood that an event will occur, such as when it will rain today. What's the chance of you winning the lottery? What's the odds of you going to college? So we're going to look at, so outcome is the result of a single trial. Okay, what's the probability of me flipping a heads on it? The outcome is a result in a single trial, so it would be 1. The event in the outcome that we're looking at, sample space, is how many times we do it. Right? So, all right, how many, what's the total possibility? So when we look at the event, rolling an even number, sample space, well, if I roll an even number, okay, on a dice, well, there's 6 numbers on it. 1, 2, 3, 4, 5, and 6. Favorable, what's up? Would be 2, 4, and 6 because those are even numbers. So we're going to look at simple probability, and then we're going to look at compound inequality. Just understand, the closer the number is to 0, the less likely it is to occur. The closer it gets to 100%, more likely it's going to happen. So percent, when we're talking about probability, the highest it could be is 100%. You can be 100% sure. Or if it's impossible for it to happen, we'd say it's 0% chance of it happening. Bowl contains 12 slips of paper. So when we go ahead and set up a proportion, we're just going to put the probability. So it's going to be a proportion. And our denominator will be all possible outcomes. In our numerator, will be the one that we're interested in. So we have 12 slips of paper, each with a different name of the month. So January, February, March, April, May, June, July, August, September, October, November, and December. So find the theoretical probability that a slip selected at random from a bowl has a name that starts with J. So our months that start, so we have a total of 12 months, so that would be our denominator. We have January, June, July, are our months that starts with J. So it would be 3 out of 12, and you would reduce that down to 1/4. So 1 out of 4 chances that you pull a month that starts with J. All right, suppose you write the days of week. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday on a piece of paper. You put it in. What's the probability that the day starts with a T? So once again, think about it. Tuesday, Thursday would be our only 2. So again, we'd say the total number of days, the total number of possibilities is 7. Right? What we're looking for are days with T, so that would be 2 out of 7. We can't simplify that down, so we could leave it just like that. You can write it as a percent. All I'm going to ask you to do is write it like this. Right? On a popular TV game show, a contestant chooses 1 of 5 envelopes. 1 envelope contains a grand prize, a car. Find the probability of choosing the car. Right? So the probability of choosing a car, there's 5 envelopes. The probability of choosing a car is 1, so it'd be 1 out of 5, or 20%. So what's the probability of not choosing the car? So if it's 1 out of 5 to get it, then it's 4 out of 5 to not get it. So if you were to add more envelopes to it, what would happen to your probability of not choosing the car? So let's say there were 10 envelopes. Still, only 1 envelope contains the car. Well, as you add more envelopes, your likelihood of getting the car would decrease. Last example about this. This is one that you may get. So after receiving complaints about the skateboards were breaking, okay, they wanted to test it. So they inspected 1,000 of these skateboards. They found no defects in 992. All right? What is the probability that the skateboard selected at random has no defects? Okay, what's the probability it doesn't have any defects? Well, there's 1,000 total skateboards that we checked. 992 don't have any defects, so it's a 992 out of 1,000. One thing and then we could convert that, it says write it as a probability as a percent, so it's about 99.2%. One thing I want to point out too is this next question is asking the opposite, or not this question, but there could be a question that asks the opposite. What's the probability it doesn't have a defect? or it does have a defect, which would be 8 out of 1,000. All right, so now we're going to look at compound probability. Compound probability is the probability of 2 or more events happening. So to find compound probability, I first want to look at is it independent or dependent? Do the events affect each other or not affect each other? Events that don't affect each other, if I roll 2 dice, they're not affecting one another. It's not like if this one rolls a 3, then this one has to roll a 5 or anything like that. They may bump, but that's not affecting their outcome. It's not changing their outcome. So that would be an independent event. Independent also too is if you could say I roll a dice, I pick a card. They don't affect one another. They're not changing one another. If I have, so that's when we look at dependent. They affect one another. They change. So if I'm drawing cards, I draw one card out and then I draw a second card out. If I don't replace that first card, then it's changed it. I went from 52 cards in my deck to now 51 in my deck. So that's what we're looking about when we talk about it. One thing that they'll say is with replacement or without replacement. If it's with replacement, meaning they're replacing the card, that would be independent. You're starting all over again. You drew an ace, they replace that back with an ace. If they say without replacement, that means it's dependent. It's affecting one another. I drew a marble, I'm not replacing it, and then I draw another marble. My sample size reduced. It went down by 1. So what we're going to do is we're going to find the probability of each event occurs, and then we multiply those 2 probabilities together, and that's how we find the total. So find the probability that you roll a 3 on one dice and an even number on another dice. Okay, so what's the probability of rolling a 3? Well, there's only 1 3 on a dice, so that'd be 1 out of 6. What's the probability of getting an even number? Well, these dice don't affect each other, so I got 1 out of 6. So probability of getting an even number would be 2, 4, 6, or 3 out of 6, or we could write that as 1/2. So we have 1/6 for getting the number 3, and 1 out of 2 for getting an even number. So we'd multiply those together. So 1/6 times 1/2 is 1/12. So the probability of getting a 3 and an even number is 1 out of 12. Find the probability that you will draw hearts and then a 4 with replacement. So we draw a card and then we're going to replace it. So what's the probability of drawing a hearts? So there's 13 hearts. So it'd be 13 out of 52, or 1/4. What's the probability of getting a 4? Well, there's 4 4s. So it'd be 4 out of 52, or 1/3. So we multiply 1/4 times 1 out of 52, or 1/4 times 1/13, which gives me 1 out of 52. So it'd take me 52 draws, 52 times of doing this over and over, all right, theoretically, to get it to happen 1 time. All right, suppose you have 7 blue tiles and 8 red tiles. What's the probability of drawing a blue tile and then a red tile without replacing it? So we are not replacing it. So if we're not replacing it, it's dependent, it's going to affect it. So I draw, okay, what's the probability of getting a blue? So that would be 7 out of the total. 7 plus 8 is 15. So 7 out of 15. What's the probability now of getting a red tile? Well, I picked out 1 tile, right? There's 8 red tiles left, so it'd be 8 out of 14. Or you could say 4 7s. So look at, our sample size went from 15 to 14 because I drew a tile out. We're saying we got this blue tile, now what's the probability of getting a red one? Multiply these two together, 7 out of 15 times 4 7, so 7 times 4 is 28, 15 times 7 is 105, which would be 4/15, would be the probability of this happening. Let me do another one. Okay, what's the probability of drawing a blue tile and then another blue tile? So think again about this. Getting a blue would be 7 out of 15. Now, you drew a blue out, so how many blues are left? 6. Okay, it also means our total went down by 1 as well, so we're at 14. So we can simplify that to 3 7s. So we go 7 15ths times 3 7s, which equal 21 over 105. Or we could simplify it down to 3 15ths. So that's our example. So compound inequality checking. So checking to see if it's independent versus dependent.